Bismillahirrahmanirrahim. Assalamu alaikum, students. In the last lecture, we started our elementary mathematics unit in detail. We discussed the idea of function. So today, we continue with that idea. So let me write here, find my pen. So I write here continue. So we continue the idea of function today. So in the last lecture, let me summarize quickly. We talked about variable. We said variable is used to represent any one of a given set of numbers. Constant represents just one number. We define set as a collection of objects. The objects can be mathematical or non-mathematical. Then we said in function we have two kinds of sets. Uh, for example, we have set x, set y. Then if there is a correspondence between the elements of these sets in such a way that uh, to an arbitrary number x of the first set x is connected and exactly one number y of the set y, then y is a function of x. We call y dependent variable, x independent variable. Then we said we can define function through a table, or we can use the formula like we expressed this function in this table as y is equal to f by x plus 2. So f of x here is x plus 2. Then we said if there is some function, then it has range, it has domain. Domain is the set of x, all the values in the set x, and range are all the values of y which are connected through this function with the values of x, right? So then we said that the function can be single valued if to each value of y in its range there corresponds just to one value of x, otherwise the function is multivalued. For example, y is equal to x plus 3 is a single valued function. You can have a multi-valued function like y is equal to x square. You can see corresponding to each y, there are two values of x connected to one y, right? Here, this y is equal to x square is a two-valued function. If x is 2, y is 4. If x is minus 2, y is still 4. So it's a two-valued function. Then we talked about representing mathematically the function. You can use these small letters f of x, g of x. Now, if there is some function, when we write f of minus 2, that means it is the value of the function when x is minus 2. So you have simply you have to put the value of x to get the value of the function at that particular value of x, right? So let us continue. We talked about domain and range. So let us move now to today's topic. Let me change the color of the background. Let me use today this color of the background. Okay, let me use red to write. So today we will now move to the next topic. First thing, one thing I want to add, if the function y is equal to f of x is such that for every y, in the range, everywhere in the range, there is one and only one and only one x in the domain such that such that y is equal to f of x. So let me write it this way. So if we have this way function, we have already discussed it. We call that time it's this function as a single valued. By single valued, we set corresponding to every y in the range of the function, there is one and only one value of x in the domain. Then this function f has another name. It is called one to one correspondence. One to one correspondence means what? We have function in such a way that corresponding to every y in the range, there is one and only one x in the domain. As we last time named it as a single valued function, it is also called the one to one correspondence. And it has another name, one to one correspondences. That means such functions which are one to one correspondences or which are single valued functions, they I think we should not say this way. We should say all one-to-one correspondences in which corresponding to each y in the range there is only one and only one x in the domain. We call such one-to-one correspondences as bijections, right? So we sometimes call these functions as bijections. Remember, all functions of the form ax plus by plus c is equal to 0 are bijections. Whenever you have a, b, c are constants, whenever you have such kind of function, which can be expressed this way, ax plus by plus c is equal to 0, then those functions are one-to-one correspondences or bijections. Remember, if you take this function, which we have already discussed, y is equal to x square, which is a two-valued function, it is not a bijection, not a bijection. If corresponding to, for example, y equal to 4, there is x equal to as well as x equal to minus 2. Now I give you a question. Question is y is equal to x cube a bijection, right? Is y equal to x cube a bijection? Think about this for a minute. And when you think, you will notice that y is equal to x cube is a bijection. So your answer here will be yes, right? Because if you, for example, take y1 corresponding to y1, if you put x1, 1 cube is 1, right? Then if you take x as minus 1, then y will become minus 1. That means for y1, there is just x equal to 1 corresponding to y equal to 1. Only x is equal to 1 is connected to that, right? Not like y is equal to x square. When corresponding to, for example, y equal to 4, we said x can be 2 as well as minus 2. Here is not that case. Corresponding to each value of y, you will have only one and only one value of x. So y is equal to x cube is a bijection. It is a one-to-one correspondence, right? One more thing, we can have a function, a variable. For example, let me talk this way. We can have a variable w which can depend simultaneously on many variables. For example, this w can depend simultaneously on x, y, and z, right? Now, if corresponding to the now w here is the, let me first write it. It is now dependent variable, and x, y, and z, the variables on which it depends, are independent variables, right? Now, if for each value of the variables x, y, z, there corresponds exactly one value of w, right? So we say that w is the function of x, y, and z. For example, if you take volume of a rectangular parallelepiped of dimensions, for example, if V is the volume of a parallelepiped, remember parallelepiped has three dimensions, and if the dimensions are x, y, and z, so you can write V is equal to x, y, z. Multiply the dimensions of the parallelepiped, you get its volume. So you can see that V is a function of three independent variables here. Because if you take any combination of x, y, z, any combination of the dimensions of the parallelepiped, you get a single value of the volume of the parallelepiped. So we can have a function which depends on multiple variables, right? Multiple independent variables. Let us move to some simple questions. To some simple questions to further improve our knowledge of the function. I take red pen. Let me write a question. Let me name question one. Represent graphically each of the following range. Remember, variable has a range. Similarly, function has a range. Question is this way: represent graphically each of the following ranges. Okay, x greater than 2. That yeah, let me do it this way: x greater than minus. When I say x is greater than minus 2, that means x can have any value greater than minus 2 on the number line. So if it is my number line, this is my number line. If this, let me use another color. If this is here, this point represents minus 2. Remember, minus 2 is not included in the range of x. It is said x is greater than minus 2. That means x can be any value greater than minus 2, but not minus 2. So that means you have to shade all the number line to the right of minus 2. All these real numbers to the right of minus 2, not minus 2, represent this range graphically. Right? So let me do another part B. If x is less than 5, that means x can be any number less than 5, but not 5. So it is here 5, for example. So all this number line represents this range, not 5. Only those numbers which are to the left of 5, not 5. All numbers which are less than 5. Right? Let me do another thing. If I have x is less than or equal to minus 1, it's a different situation. It means x can be any number less than minus 1 to the left of minus 1, and x can be equal to minus 1. So here you have to shade the minus 1 point as well. So if this is my minus 1 point, now I make it filled circle, not empty circle, because minus 1 is also included in the range of x. So graphically, all the numbers to the left of minus 1 as well as minus 1 is the my range of x, right? Compared with part A and part B, where minus 2 and 5 were excluded from the range, but in this part C, minus 1 is included in the range. Let me do another thing. If I write it this way, minus 3 is less than x and x itself is less than 4. Now, what is the graphical representation of this range? That means x is less than 4, not 4. But x is greater than minus 3 also, and not minus 3. That means all the numbers between minus 3 and 4, excluding minus 3 and 4, represent this range. So if this is minus 3 and this number is 4, they are not included, only the numbers in between is the range of my variable x, right? Minus 3 to 4. In between minus 3 and 4, not minus 3 and 4, right? So let us move to next part E. If it is written this way, minus 2 less than x less than 2, right? That means x is less than 2 and greater than minus 2. So the same situation this way. If this is my minus 2 and this is my, sorry, let me write it with an empty circle. 2 is not included. So it is my 2. So x is any number between minus 2 and 2, right? This is mathematically also written mod x is less than 2. Remember, mod x is always positive. Whether x is negative or positive, mod x is a positive number. So this x between minus 2 and 2 is simply written as mod x is less than 2. Then the distance of all the points in the range of x from the origin is less than 2 lengthwise. There will be 0 between minus 2 and 2. So if you take the distance of any point to the right of origin or to the left of origin, they are all less than 2 length of distance of those points from the point 0, right? So whether you write it this way or that way, it is one and the same thing. Let me do another part. If it is written mod x is greater than 3, what is the meaning of it? It means this. If this is my number line, this is here minus 3, then there will be some other point to the right, which is 3. So all the numbers to the right of 3, not 3, and all the numbers to the left of minus 3, do it clearly. All the numbers to the left of 3, sorry, minus 3, not minus 3, constitute this range. Because I am saying mod x is greater than 3. You can see in this between there is a origin 0. So distance of all the points to the right of 3 from origin is greater than 3, and minus 3, because mod, when x is minus 3, mod x is still 3. When you say x is minus, mod x is still plus x. So all the distance of all the points to the left of minus 3 is greater than 3. So this mathematically means these points to the left of minus 3 and to the right of plus 3, excluding minus 3 and plus 3. So let me do next here G. If it is written minus 3 is less than or equal to x is less than or equal to 5. How we represent this range graphically? See, x is greater than minus 3, but it is also equal to minus 3, and it is less than 5 and equal to 5. So 5 and minus 3 are also included in the range. So if this is here minus 3, see, and this here is 5. Remember, I am now here filling the circle because minus 3 is included. So all the numbers between minus 3 and 5, including minus 3 and 5, is the range of this variable when I write it this way. Minus 3 less than or equal to x, less than or equal to 5. Let me do one more. We have h, part h, x is less than or equal to minus 3 and x is greater than or equal to 4. It is simple. You can see x is all the points equal to minus 3 and less than minus 3, and all the points greater than and equal to 4 comprise the range. That means if this is my minus 3, it is also included, and this is 4, it is also included. So all numbers which are less than minus 3, that is these numbers, and also minus 3 includes in the range, and all the numbers which are to the right of 4 including 4 comprise my range, right? So there is no point between minus 3 and 4 which corresponds to range, only this zone including minus 3 and this zone including 4, right? Let us do one more question. Question 2, I call it question 2. Let me use red. Question is like this: given f of x equal to x square minus 5x plus 4, find. We have given a function, now we have to find. Part A says find f of 0. Simple. We have to put in this function instead of x 0. So what we get? F of 0 is 0 square minus 5 into 0 plus 4. What is that? That is 0 minus 0 plus 4, which is 4. So our answer here is 4. F of 0 is 4 in this case. It clearly. So it is 4, right? So let us do part B. It says find f of 2. Simple. Put 2 instead of x. So it is 2 square minus 5 into 2 plus 4. What is that? That is 4 minus 5 2s are 10 plus 4. That is 8 minus 10. That is minus 2. So here f of 2 for this function is minus 2. That means if x attains the value minus 2, this particular function, sorry, if f(x) attains the value 2, this function attains the value minus 2, right? So let us move to part C. It says find f of minus. Let's find f of minus 3. Put minus 3 in the function instead of x. That is minus 3 square minus 5 into minus 3 plus 4. What is that equal to? Minus 3 square is 9. Then minus times minus is plus. 5 3s are 15 plus 4. What is that? That is 13 plus 15, 28. So f of minus 3 is 28. Let us do another thing. This D, what is f of a? That means instead of x, I have to write a. That is a square minus 5a plus 4. So this is my answer. A square minus 5a plus 4 is f of a. Let us do another thing. F of minus x. We have to put minus x instead of x. Put that. That means minus x square minus 5 into minus x plus 4. What is that? Minus x square is x square. Minus times minus is plus. So it is plus 5x plus 4. So x square plus 5x minus, x square plus 5x plus 4 is f of minus x, right? Then let me do another part. F, it says what is f of b plus 1? That means instead of b plus x, you have to write uh, b plus 1. That means it is, instead of x, I write b plus 1. So it is b plus 1 square minus 5 times, instead of x, I have to write b plus 1 plus 4. When I solve it, I will write directly. It will become b square minus 3b. F of b plus 1 is, instead of x, you write b plus 1 square minus 5 times b plus 1 plus 4. Then you simplify it. You use here a plus b ka whole square. Then you simplify it. You will get b square minus 3b. So here f of b plus 1 is b square. This is b square minus 3b. Check it at home yourself. Check it. Then let me do another part. G. I said, what is f of 3x? So instead of x, write 3x. That means it is 3x square minus 5 times 3x plus 4. 3x square minus 5 times 3x plus 4. When you solve it, what it becomes? It becomes 9x square, 3x whole square, 9x square minus 15x plus 4. So f of 3x is 9x square minus 15x plus 4. This is your another answer. Let me go to another part. H. What is f of x plus a minus f of a? It is lengthy. First, you have to find f of x plus a. Then you have to subtract from that f of a. So, what's my f of x plus a? My f of x plus a, I have to put instead of x plus a in the function. So it is x plus a square minus 5 times x plus a plus 4. This whole thing is my f of x plus a. Then I have to subtract from it minus f of a. What is that? That is a square minus 5a plus 4. This whole thing is my f of x plus a. This whole thing is my f of a. So it is f of x plus a minus f of a, right? So when you simplify it, I will write directly. You will check it at your home. It turns out to be, let me write this in red, x square plus 2ax minus 5x. We encircle it. This is my f of x plus a minus f of a. X square plus 2ax minus 5x. So I stop here. I hope you enjoyed this class. Now you know the function, you know the range, domain, you know the dependent variable, independent variable, all this terminology. You know how to find the value of function at a particular value of independent variable. So don't forget to like, share, and subscribe my channel. Thank you. Assalamu alaikum.